Okay, so this is out of section 8.4 still. We were dealing with parametric equations. This says, determine the parametric equation of the line that has slope 1, 2, passing through the point 4, negative 1. Now remember how we wrote parametric equations? We're going to have x written as some equation with t's in it, and we're going to have y written as some equation with t's in it. So what do we know about x and y? Anything? In context of the information given. I know the slope. I know the slope is 1/2. That tells me something about x's and y's, doesn't it? What's that tell me about x's and y's? Every time the y goes up 1, the x goes up 2. Okay? What does this tell me? That's an x and a y, isn't it? All right. So I know x at some point had to be 4, and I know y at some point had to be negative 1. But we also, just a second ago, said something about x's and y's going up and over. So x isn't always 4, and y isn't always negative 1. So how do I write y goes up 1 when x goes up 2? Well, if I were to add a t here, every time t got bigger, y would go up 1, wouldn't it? If t was 1, y would go up 1. If t were 2, it would go up 1 again, so on and so forth. So there's how to indicate y goes up 1. How do I make x go up 2? 2t. There's the parametric equations. It goes through the point 4, negative 1, and every time y goes up 1, x goes up 2. All right, so that wasn't as bad as it looked. How would you find the line through the points 6, 7, and 7, 8? I would find the slope first. Okay, what's the slope? You were right the first time. Or the easy thing I would have done is I would have said, look, the y's went from 7 to 8, so the y's went up 1. The x's went from 6 to 7, so the x's went up. So when y goes up 1, x goes up 1. So the slope is 1. You guys are making it too hard. So again, my parametric equations, x equals y equals, what's x? 6 plus t, and y is 7 plus t, because this time they're both going up 1. When x goes up 1, y goes up 1. So I just need t and t here. It would not matter. Another correct answer would be x equals 7 plus t, and y equals 8 plus t. That would be another correct answer. Give me more than one correct answer here. All right, the last thing in this section is using your calculator. On your calculator, before we push this mode button, and we found that there was a polar mode, and we use that to graph polar equations. There also happens to be par, and par stands for parametric. So switch your calculator to parametric mode. I go y equals. So it gives me x1 at t. So I guess I'll use this answer that I had here, 4 plus 2t. 4 plus 2. To get t, I hit the button that I usually hit for x, and it gives me t. And then y was negative 1 plus t. You have to put in the x and the y. And if I hit graph, that one should just be a line. Now, why is it only giving me part of the line? Why is it starting there and only going to the right? It assumes t is only positive numbers. So what you might want to do is hit window. My t is going from 0 to 6.28. It looks like my t is going from 0 to 2 pi. 6.28 looks like 2 pi. You might want to make t go from negative 10 to positive 10, for example. And then it does graph the whole line. All right, but again, parametric equations can be used to make, interesting fancy graphs. For example, maybe we want cosine of 6t here, and maybe we want 5 sine of 4t there. I don't know, I'm just making stuff up. And you can see you get interesting curves. Not really easy to see on the screen there, but again, parametric equations are used very, very heavily in computer programming to get interesting shapes like that. And you do what? Make a draft. I don't know what that means. Make a giraffe. Oh, I thought you said make a draft. I don't know the equations for making a giraffe, but you could come up with one, I suppose. I bet Google you could find them. So anyway, you can see what parametric equations are used for. You can get very interesting pictures, very intricate detail. Okay? Questions on that?